This question is about fuels. The petroleum fraction obtained from crude oil can be used as fuel in cars. State the meaning of fraction as used in the term petroleum fraction. So a fraction is the group of compounds that have a similar size and a similar boiling point. So when we're doing our fractional distillation, we're getting these groups of compounds that have similar boiling points off together as a fraction. In petroleum fractional distillation, they tend to be hydrocarbons, but you could just say a group of compounds, or you could say a group of hydrocarbons. So with similar boiling points, they have similar sizes. That's why they come off together. Hexadecane, so that's an alkane, can be cracked at high temperature to form petrol. Complete the equation to show the cracking of one molecule of hexadecane, so they've already drawn that in for us, to form hexane, so hex meaning 6, and ane meaning alkane, so 2n plus 2, so double it and add 2, 14. Cyclopentane, so pent meaning 5, but a cyclic alkane only has 2n hydrogens, so C5H10. So it says these things only. So we've got our formulas, and now we need to balance our equation. So we had 16 carbons altogether, so the way to get 16 carbons out of 6 and a 5 is to have 2 lots of 5 to get us to 10. And if we check the hydrogens, then we've got 20 hydrogens in the cyclopentanes and another 14, that gets us to 34. And then it says, give the name of the catalyst used in this cracking reaction. So this is catalytic cracking to make cyclic alkane. And so catalytic cracking uses a zeolite catalyst. So if you can remember, thermal cracking is high temperature and high pressure, no catalyst, and catalytic cracking is a high temperature, a slight pressure, and a zeolite catalyst. And I always say, if you can remember the sort of little phrase, high, slight, zeolite, then it kind of sticks in your mind. It's a high temperature, a slight pressure, and a zeolite catalyst. High, slight, zeolite, sounding the same. Carbon dioxide is formed when petrol is burned. Carbon dioxide acts as a greenhouse gas when it absorbs infrared radiation. Give a reason why carbon dioxide absorbs infrared radiation. And infrared radiation is absorbed when bonds vibrate. So what bonds are in carbon dioxide? C double bond O bonds. And the reason they do this is because they are polar and vibrate at the same frequency as infrared. Compound Z, which they've given us the formula of, can be used to remove carbon dioxide from the mixture of waste gases produced in power stations. Figure 1 shows the suggested mechanism for the reaction of Z with carbon dioxide. Draw 2 curly arrows to complete the mechanism in figure 1. So if we look at step 1, we can see a curly arrow from a lone pair on a nitrogen, nucleophilic attack of a delta plus carbon, and then we've opened up the double bond, and then we can see that that is the end of step 1. There's nothing else needing to happen to achieve the products of step 1, because the nitrogens become positive because it gave away an electron from the lone pair, and the oxygens become negative. As a result, we've moved the electrons from the double bond onto the oxygen, so I'm going to put a lone pair there. And then if we look down at the bottom, we can see that, I'm just going to use the little highlighter, we can see that this part has become this. Yeah? And so it's picked up a proton. Okay, and if we look at what's lost a proton, we can see that the N has lost a proton. So this lone pair is going to go and get this hydrogen. So the bond that holds it onto the nitrogen is going to break and put the electrons back onto the nitrogen. That's losing that plus charge on the nitrogen. So we can see that in the product. And that is the 2 curly arrows they want us to add. We're not going to reform that double bond on the oxygen because we can see that it's still a minus charged oxygen in the product. It says name compound Z, so this is our compound. So the main functional group in this is the alcohol, because it's hard to name it an amine. So we're going to go 1, 2, so it's ethanol, and it's got that amine group on number 2, so 2-amino ethanol. Now, if you named it as an amine, it would be ethylamine. It would be 2-hydroxyethylamine. Deduce the role of Z in step 2 of the mechanism. So we can see that in step 2 is where our lone pair on our nitrogen went to accept a proton. And if something is a proton acceptor, then it is a base. 2.5. So an amino ethanol can be represented as XNH2, and our ammonium salt that we made can be represented as XNH3. Draw the shape of XNH2. So nitrogen is in group 5, and we've got an X and 2 H's, so we've got 3 bonds attached, no charge, so that's 8 electrons or 4 pairs. Now we've only got 3 things attached, so we're doing 3 bond pairs and 1 lone pair around the nitrogen. So we're going for this pyramidal shape, 3 bond pairs and 1 lone pair. One of these is an X, 2 of them are H's. This is our structure. And then over here, similar thing, nitrogen's in group 5. This time we've got an X and 3 hydrogens, so 4 things attached. We've got a plus charge, so we're going to minus 1 electron for that. So that's 8 electrons in total, 4 pairs, and they're all bonds. So this time it's 4 bond pairs and no lone pairs. So we're going for that tetrahedral structure. That last bond has been a coordinate bond from the lone pair on the nitrogen. And it says, state whether the HNH bond angle, so this bond angle in XNH2 is greater than the same as or smaller than that in XNH3. Well, this is pyramidal, 107 degrees, pushed down by the lone pair because lone pairs have greater repulsion, whereas the other one is tetrahedral, equal repulsion from the bonds, pairs. Okay, so the bond angle would be smaller in XNH2, and that is because in the other structure, in our XNH2, we've got a lone pair, and lone pairs repel more than bonding pairs. And then our question continues with what looks like a level of response question. Bioethanol is used as an alternative to fossil fuels. This statement appears on a website. The fact that bioethanol is a carbon neutral fuel outweighs the environmental disadvantage of producing bioethanol. Evaluate this statement. In your answer, you should include an outline of how bioethanol is produced, relevant equations, and analysis of the environmental impact. So let's start with bioethanol. So bioethanol has to be made in a sustainable manner. So the first thing that happens is that photosynthesis removes CO2 from the atmosphere. Okay, and our equation for that would be 6 CO2 and 6 H2O. So carbon dioxide and water come together to make glucose and oxygen. That's our photosynthesis equation. And then what we do is we're going to ferment that sugar to produce the ethanol, the bioethanol. Fermentation produces bioethanol from glucose made by fermentation. So we take our C6H12O6, use some yeast, and we get 2 lots of ethanol and 2 lots of carbon dioxide. And then combustion produces the energy as the fuel. And remember we had 2 lots of bioethanol that we just made. So we're going to combust those in oxygen and we're going to make carbon dioxide. So we've got 4 C's all together. We've got 6 H's, so 6 waters. And if we balance the oxygens on that, we've got 8 plus 6 is 14. Take away 2, so we need 6. So we can see that in total, 6, if we have a look, 6 CO2s removed from the atmosphere, 6 CO2s produced and put back into the atmosphere. Okay, so we have 6 CO2 removed from atmosphere in photosynthesis, but total of 6 CO2s put back into atmosphere via fermentation and combustion. But not technically carbon neutral as fuel is used in production and distribution, transportation. So it's technically not a carbon neutral fuel. Let's have a look at the other part of the question. Bioethanol is a carbon neutral fuel, outweighs the environmental disadvantages. So what other environmental disadvantages are there of producing bioethanol? Well, to produce bioethanol, there will also be issues such as deforestation, to have land to grow sugar, which results in loss of habitat and biodiversity. So although this may be better than in terms of carbon into the atmosphere from burning a regular fossil fuel, there are other considerations you need to think about and just write about in your answer.